are we looking for? Besides just telling me that we're looking for D, like what specifically are we looking for here? It is an angle, good, yeah. And I know it was forever ago, but well, on the notes it says that when you're gonna find an angle, what type of operation are you gonna end up using? On that first page, towards the bottom, it literally says to find angle, and then huh? We need to use the inverse operation. We don't know which one it is yet. We haven't gotten into it, but it's going to be the one with the little -1 that looks like it has a little exponent on top, and then you have to hit shift on your calculator to find. So, not that you have to do this, and eventually when you get better at these, you can kind of bypass certain steps. But let's get back in the habit of writing a trig equation. The first thing we need to write is which trig function we're going to use. After that comes the angle, which that one we know is going to be D. Okay, and then we write our trig ratio, which is some side over some side. Now we know the sides are giving us our 107 and 128, but just as important as that is being able to use our trig words. The trig words were opposite, adjacent, and hypotenuse. Opposite and adjacent are the legs. Hypotenuse is the one across from the 90. So obviously here they're giving us the two legs. So which leg is opposite of D? 107. Which leg is adjacent to D? The 128. So which trig ratio relates opposite with adjacent? What's the TOA and SOHCAHTOA? Yeah, so I know this is going to be tangent of D, and then it specifically has to be the opposite on top over the adjacent. But this is just an arrangement. Instead of trying to show you algebraically how to isolate the variable, I found that it's easier just to show the kids, look, go ahead and isolate D already. And as long as you know that D is an angle, you know that for to find angles, we need inverse operations. Because the original equation had a tangent in it, we're going to hit inverse tangent. Tangent with a little -1 on top. And then you got to do 107 divided by 128. How you key that in, like this is a calculator lesson. Half the battle is knowing how to use your calculator. If you have a calculator that has live entry where like it blinks at you and you have a 2-line display, you can just type it as you see it. And to practice and make sure you get in. Also remember to make sure that your calculator is set to degrees. It should have either a D or a DEG on the screen showing. And then you're going to have to round. Yeah, I found in my experience that a lot of times when we go looking for angles, they usually ask you to round to the nearest degree. So you're getting what, 40, Scotty? Yeah, be around 40. And I think that's what they had at the top, right? Anything else would be like a rounding. It depends on what they tell you to round to. 39 point something. Did anybody not get that 40 on the calculator? Tangent button, tangent smooth, hit the blue button. I'll put in 107 divided by 128. Any questions there? Okay, these are real simple ones. This is just calculator practice. They've already told you what to put into the calculator. all what they want to know here is what the ratio is, but they want it as a like the trig equation is here's the function, there's the angle, it's equal to. It's just they want to know what's on this side, but instead of writing it as a fraction, they just want it as a decimal to the nearest 10,000. Just hit sine of 6. What does sine of 6 give you approximately to the nearest 10,000? So we can get through as many examples as possible before the bell rings. What'd you get? Seriously? I just need one person. If just one person would be willing to contribute, you don't have a okay. At least you tried. 0.1045. That is to the 10,000. That's 4 decimal places. Let's do the same thing with cosine of 77. Just so that you understand what they've already done is just like the equation we just wrote. All what we're doing is expressing that fraction that's there as a decimal. 0. What? 450. Patty, do you agree? It's 4 decimal places. 250. Yeah, it would be 250. Find the measure of an angle. This is similar to the first one that we did. In order to find angles, what do? What do we end up using in order to find angles? The inverse one, right? Well, here, look, they've already written the trig equation for you. What we did over here, writing the equation, they've already done for you. The only difference is they're expressing the fraction as a decimal. All you need to do is say, okay, well, if this is using cosine, in order to find C, I'm now going to hit inverse cosine, and then I'll just put that decimal. Look to the nearest tenth of a degree. I normally see them asking for angles to the nearest degree, but fine, this one said tenth of a degree, so give me to the nearest tenth of a degree. 75.1. 75.6. If I'm going too fast, let me know, I'll stop. Here we're looking for x. What is x? Not like as a number, but like as a object. What is x? Angle. In order to find angles, we need inverse trig functions. I'll just go through the I'll go through the process of writing the equation, but not that you need the equation. We know that x is the angle. I don't know what trig function, and I don't know what the fraction is going to be, but I know that the 12 and the 17 are going to be there. What side is the 12? Opposite. What side is the 17? So what trig ratio relates opposite with hypotenuse? Sine. So I know I'm going to have a sine here, and then specifically with sine, opposite has to go on top, and hypotenuse has to go on the bottom. The sine is opposite over hypotenuse. So in order to find x, we know that to find angles, you need the inverse. So x would be inverse sine of over 17. I thought, does somebody here have a one-line display calculator? I thought somebody had a one-line display. Because those you gotta put the division first, and then you gotta hit the inverse sine. What'd you get? 45? Anybody disagree with that? They want it to the nearest 10. Any questions there? Okay, what are we looking for here? We're looking for a side, okay? So I know the angle is going to be 31. I don't know what trig ratio to put yet. But I know the sides are x and 34. So it's just knowing which sides. What side is x based on that the 31-degree angle? That is the adjacent leg, yeah. The 34 is the no, it's the hypotenuse. 34 is the hypotenuse. So what relates what trig ratio relates adjacent with hypotenuse? Cosine. So I'm gonna write cosine 31. Adjacent has to go on top. Regardless of what the trig ratio is, who remembers from a week ago, where I taught you a secret. It said that if what you're looking for is on the top, you can isolate that quickly. I want to solve for x. How can I solve? 34 to the front. The key is that when you're looking for, when the number you're looking for is on top, you end up multiplying. So x is 34 cosine 31. Put that into the calculator and run. What'd you get, Scotty? 29.1 approximately. Yeah, it didn't tell us what the number was. Addie, do you agree with that? Okay. Let's see if I can find one on the bottom. Perfect. Okay, so here we're looking for G. The angle is 42, so I know the trig function is gonna go right in front of the 42, and I know that on the fraction I'm gonna have the G and the 20, but in order to know where they go, I have to know what sides they are. What side is the G here? It's the adjacent leg. It's the leg that's touching the 42. What side is the 20? Opposite leg. What trig ratio relates opposite with adjacent? 10. And then specifically in order, its opposite has to go on the top and adjacent on the bottom. So even though the trig function is different, that's not a big deal. That's just a matter of what button you're hitting on the calculator. What's more important is that the unknown is on the bottom of the fraction. So who remembers the trick I taught you when the unknown's on the bottom of the fraction? When it's on the top, you multiply. When the unknown's on the bottom, you're going to? Yeah, and how do you divide specifically? Just flip-flop these two. So then G is equal to 20 over 10. Calculator, help me out. I'm sorry? 22.2. We'll cut it off there today. Tomorrow, I'll let you decide. I still have a bunch of examples. If you want me to do a few of them and then let you work on the homework, you can do it that way. It's up to you.